All right, just so that you can see it, the parts for the rental gas estimate design are up here on my website. Part 1 is due tomorrow. Part 2 we decided is due Tuesday, and Part 3 is due a week from tomorrow. And today we're going to finish the lecture, so you're going to help me come up with due dates for all the rest of this stuff, and we'll save that for just a minute. This link up here is dead. I keep forgetting to take the link out. These are the links now, so this doesn't do anything. There is still an evaluation sheet up there if you want to pre-evaluate your designs. Here's the gas estimate. No, where'd it go? There it is. This is all 3 worksheets combined. All 3 parts. It's all combined. So when you're doing the IOP and the screen layout, you can check your stuff. You move on to the toe and the pseudocode, you can check your stuff. Flowchart, test plan. The 20 points is a lie. It's now 25 points total. When I grade your part 3, I will be using this. Because when you're done with part 3, everything should be right. So if you haven't fixed something and you're turning in part 3, you'll get dinged for it again. So make sure you do your updates. All right, back to my notes. The last phase of our design prepares us for testing our program. At this stage, we're done with level 4. We've got an algorithm that we've laid out in pseudocode and flowchart. We could take that algorithm and start writing code. And we will. You will. But when the code's done, how do you know it works? Well, most of you, hopefully, while you're writing your program, are going, okay, do a little piece. Does that work? Go up. And hit clear, and yes, it wipes out my first 2 things. And hit clear, and yes, it changed my date. Hit calculate, and yes, it calculates and displays the results. But how do you know those results are right? Well, I got an answer. Well, that doesn't mean they're right. It means you got an answer. So what we're going to do in part 5 of the test, of the design, is plan our tests. And have 3 or 4 of them, or 5 of them, that are ready, so that when you think your program's done, you run it through these 5 tests, and if it passes all 5 tests, it should be good to go. That's what we're going to plan. Once again, we're going to use our previous levels of design and carry it forward. I'm opening up meters to yards, and I'm going to create a new window so I can see both. Do I need to do that? No, I don't think so. I'm going to maximize this so I get a little more screen space. And I'm going to my pseudocode. When we test, we're not going to define a test plan for button clear. How many different ways can you clear? 1. It either works or it doesn't. All right? So I'm not writing a test plan for that. I'm not writing a test plan for exit. It either exits or it doesn't. That one I think you can handle without a plan. But the calculations, there's lots of different numbers I could put in there, lots of different goofy things I could do to see if my test works. So what we're going to do is take our pseudocode logic. Remember, all I have to do is highlight that much. Take our pseudocode logic, copy it to the clipboard, and move it to the last tab. If you can't see your tab, you can adjust the tabs, you can move with the arrows, go to the test plan. And notice here we have inputs. Oh, I'm sorry, I'm not doing this right. We have inputs, we have processing, and we have outputs. The inputs don't come from the pseudocode, they come from the IOP. Here's my input. Copy that to the test plan. Paste. My outputs are in the IOP. Copy. Paste. My processing, the details that I need for the processing, that's in the pseudocode. but only the calculations. Everything else, the inputs we've already got, the outputs we've already got, so just these calculations. Test plan, paste. I've got a lot of blank lines here. It's going to make it very hard for me to show you what's going on, so I'm going to remove these blank lines. You can leave yours in. It's going to highlight the line numbers and delete the rows. I put a lot in there in case you need them. You can always remove rows. You can always add rows. Another thing I just did is I put my cursor in cell B1 and I went window freeze. What that does is it freezes everything to the left. So I can scroll to the right and my labels here, meters, feet, yards, etc. will stick. Now I need to come up with some test data. What numbers should I put in to test my meters? Well, the first one, to test my program. The first one may be an easy number, 1. Then down here, my anticipated equation is feet equals, and what you do is you plug in the number into the variable, 1 times 3.281. You leave the variable on the left because we don't know what that's going to be. We can anticipate it. But you take your sample data and you plug it into the equations on the right-hand side. In this case, why do we care about these equations? Isn't our program just going to say 3 point something? Yes. But what if your program doesn't work? What's wrong? Is it your inputs? Is it your processing? Is it your outputs? What I'm going to show you in Unit 4 is how to use a program component called the debugger that allows you to go line by line and touch this variable meters and see what's in there. What my test plan tells me is if everything's working right, when you touch this, you should see a 1. If I don't, I know something's wrong. 1 times 3.281, so yards is equal to 3.281. That's what the feet would calculate out. If you don't know, use a calculator. I'm going to go to the Start menu, Accessories, Calculator. Now, if you're really good at Excel, you can use Excel to do some of your calculations, right? But some of you haven't gotten that far in Excel yet. You can use a calculator. I'm going to divide that by 3, because that's what this says. Take whatever the feet turned out to be, and I can do that one in my head. And this equation says take the answer from that one, 3.2, and divide it by 3. Okay, so my calculator, I say 3.281. You can just copy mine when I'm done. Divided by 3 equals 1.90936667. Okay, so here we could put that same answer. 1.093.6667 or whatever it was. How far do we want to go? We didn't say, did we, in the design? So let's just leave that whole thing in there for right now. So now if I run my program after I write it, and I haven't even written it yet, so I can't test this, I should enter 1 for meters, and when I hit calculate, I expect to see an answer similar to this. The decimal places may be continuing or maybe smaller, but that is the appropriate answer. If I did my calculator right, 1.936. So there's test number 1. You want your tests to be test-worthy, meaning they're going to stress your program a little bit, make sure it does all the right stuff the right way. So what else might I test it with? 63? Sure. 63, he says. Okay. So here, feet is going to be equal to 63 times 3.281. I'm going to minimize this window a little bit so I can see my calculator at the same time, not have to switch back and forth quite so much. Okay. I'm going to use my trusty dusty calculator. 63 times 3.281 equals 206. So down in this equation, yards equals 206.073 divided by 3. These values are here so that when we're testing, if my program doesn't work, I can use these values to debug. Try to track down where the project is, where the problem is. All the user's going to see is the 63. At the bottom of the form, when they hit calculate, they're going to see 68. Why are you frozen? It's not letting me type in there. Why not? Oh, it's way over. Why is it doing way over there? Pfft. 68.901. 68.901. Must have been resting on the keyboard or something. Okay. Give me another one. 0. Ooh, that's a good test. What happens if I put in 0 meters? What do I expect to get? 0 yards, right? So let's see how that works out. 0 feet equals 0 times 3.281. Yards equals 0 divided by 3. Uh-oh. Can I divide 0 by 3?
You'll get an error.
I will?
No, you can divide 0.
No, I can divide 0 by 3. It's the other way around.
Oh.
How many times can I put nothing in this cup for the rest of my life, right? So yes, that's acceptable. Answer better be 0. That's a good test. It's amazing how often 0 screws up your program. And if you like, these are kind of hard to read because they're pushed over. You could align them to the left. That make them a little easier to read. Need another test. Yep.
Can you try something other than a number?
Yes, in a minute. But what other kind of numbers haven't I looked at yet? A half. Numbers with decimal places in them. My program should be able to handle that, right? If we put in 13.57 meters, it should be able to handle that. But we need to make sure it is absolutely possible and easy to do for you, the programmer, to say, whoops, discard the decimal places and you'll get the wrong answer. So here, this is going to be feet equals 13.57 times 3.281. Trusty dusty calculator, 13.57 times 3.281. Okay, so down here, yards equals 44.52317 divided by 3. How many decimal places do you have to put in there? I'd say 3 is pretty good. Behind the scenes, C#, all programming languages will use as many decimal places as they can hold in their allotted space of memory. They'll use as many as they can. So showing when the calculator doesn't show you some unlimited number of decimal places, showing them all is fine. And now I need to divide that by 3. And my answer down here is 14. I think I'm just going to copy that. Should be able to. Paste. Good test. Trevor wants to do one. What happens if I don't put in a number? That's a good idea. Before I do that one, though, I'm going to back up to Isaac's. That was a 63. It's a good test. But how's that really different than 1? It's not 1. So maybe that's not a bad test. You know what? Let's just go with it. And here's test 5. There's another kind of number I haven't tested yet. Hmm? Did that.
A negative.
Negative number. How deep is the ocean? Minus 100 meters or minus 11. Let's kill a couple of birds with one stone here. We could have done that. We're testing decimal places and negative numbers all in one test. Sometimes it's not a bad idea to just take it one at a time. If I get the wrong answer here, is it because my program can't handle negatives or because it can't handle decimals? Well, I've already tested decimals. It seems to handle those pretty good, so that it's probably the negative if it doesn't work. 11 minus 11.25 times 3.281. $11.25 plus or minus times 3.281. Okay, that's what I expect. Yards equals that number. Just wing it on yours is probably okay, divided by 3. And my end result should be minus 12 and change. That's a good test. If the numbers negative are allowable or reasonable, go ahead and use them. Right here it's reasonable. 0, is that reasonable? That's a good test. So positive numbers, negative numbers, decimal numbers, 0, all good tests. The one we haven't done yet is what happens if I type in letters. So thanks to Trevor, way to go Trevor, I'm going to add a test 6. There's no rule that says you have to limit yourself to 5 tests. Right? That's just how many I require you to do as a minimum. Notice what I'm doing here. I'm using that little fill handle. This is also available in Excel. So a little square on the lower right just says copy this basically. You could also copy and paste. So text like what? Like, Trevor, stupid user. What do you think that's going to do? It's going to throw an error. Okay, so on the next equation, I get an error. I can't do the next equation. And the results will be an error. I would like you to include one and only one of these. What happens? Because in Unit 4, I'm going to show you how to capture that error and say, wait. Hey, stupid user, that's not a number, try again. I'll show you how to do that in a relatively easy way. We're not going to make our program error or dummy proof, but pretty close. And in the future, we'll make our program smart enough to say, I'm sorry, the value you entered for meters is not acceptable. Instead of, hey, dummy, something's wrong, fix your inputs. So in this case, I've dreamed up 6 tests with your help. Your requirement is 5 tests, one of which, test 5, always the last one, should be an error test. What happens if you cause an error of some kind? Save it. And let's go do bowling because it should be a little more complicated. Remember, for my test plan, I stole my inputs from the IOP. And unfortunately, it also gave me some borders, but I can get rid of those by painting from this empty cell here. The outputs come from the IAP. So I'm going back to the IAP and grab the outputs and paste them into the test plan under outputs. And finally, the calculations come from the pseudocode. Just the calculations is all I need for processing, because this is really taken care of by input and this is taken care of by output. God, I should have read up on this and I should have looked at last year's solution. I'll accept it. It'll work. And I'm going to scroll down so I can get rid of some excess rows so we can see everything at once. You don't have to do this. I'm just doing it so that we can see things a little bit better. I click in B1, window, freeze. And now when I scroll to the side, that left column freezes so it doesn't scroll away. If you're using small text on a pretty big monitor, then you don't need to necessarily do that stuff. All right, now we need some test data. Let's just put in some good sample data here, like Volker Gall. Okay. Bowling date, pick today's date, 9/18/2014. What about the format? Doesn't matter, as long as it's readable. Some of you are using really goofy formats still in your change logs. As long as everybody else understands that date format. Sample score, let's keep it simple. 100, 100, 100. Down here, the series is equal to 100 plus 100 plus 100. The average, because of the way we did it, is equal to 100 plus 100 plus 100 divided by 3. And the next bowling date, and this gets a little tricky sometimes, the next bowling date is equal to 9/18/14 plus 14. I'm going to leave out the days. I'm just plugging in my test data into these formulas on the right-hand side of the equal sign. Plug the test data into the right-hand side of the equal sign. My anticipated results, 300. 100.0 because we did say in the pseudocode flowchart that we want one decimal place there. And the next bowling date is 32nd of, I'm adding 14 to 18, that's the 32nd of September, so that's the 2nd of October. If you're not sure, look it up. Click on the calendar, 2 weeks from today, 2nd of October. So that, my first test is usually some reasonable kind of data. So now, what other kind of things can we test? What if we leave the name lowercase? What? I'm Batman. What about the bowling date?
April 4th,
1958, boy, that's going back in time. Not bad. Why April 4th? It's a date. Why not? All right. Maybe we can pick a day where we'll say why. Why? Because 14 days beyond that is going to go into the next year. I recommend that you always include a late December date in your tests so that you can ensure that it does go to January, whatever that is, on the 14th. It crosses the months. We already tested, because today's the 18th, we've already tested the crossing a month boundary just to be safe. But if you do this, you're crossing months and years all at the same time. It's a good test. Scores. 72, why? It's a number. How about minus numbers? Bowlers. Nobody sucks that bad. It's not recording, darn it. Nobody's that bad at bowling. Okay, so negative numbers are really not a good test here, because in the future when you gain some programming skills, maybe a negative number we'd put in just to make sure the program really throws up on it, but here it's not gonna. 301, can't do that. But I can bowl 0, right? That's always a good test. Let's put a bunch of zeros in. That should be easy to do the math then. Series equals 0 plus 0 plus 0. And the next bowling date equals 12, 22, 13, plus 14 days. And I'm stretching my columns so that the data fits. Remember, you go to the D up at the top and stretch the right edge. Anticipated results. My series better be 0. My average, 0.0. And the next bowling date, oh, this is tricky. Let's see, if I add 14 to that, that's the 36th, minus 31, that's the 5th of January. If you're not understanding what I'm doing, don't worry about it, look it up. I expect it to be the 5th. But this brings up a point. What if I do the math wrong in my head? I think I know what I'm doing and I do it wrong. Your program's going to give you a different answer. And now the challenge becomes, what's wrong, your program or the test data? Could be either one. First thing I would do is double check my test data, maybe get the calculator out, get the calendar for 2012 or 14 out, and check that. Those of you that know Excel, you can write formulas to do this stuff and have Excel tell you, and it will work. See a couple of you getting out your phone calculators. Perfect. Why, I have a little one over here on the side. Get your phone calculators up. But most spreadsheets will do a lot of this math for you if you know how to enter the formulas. If you don't, this is what I'm asking you to do. Okay, what else can we screw up here? Let's leave the name blank. See if that causes any trouble. Dates. How about a leap year? If you really want to, which leap year is a leap year? 12 was a leap year, I think. So, okay, 1/31/2012. Is that what I'm looking for? No. 2/27/2012. Hope you got your calendar handy. So now you got to help me figure out what the right date is. What else can I do to these? Can I put decimal places on them? No? Just can't bowl a half a pin. I'd love to sometimes. That wobbly one, let's count that. No. But what I haven't done yet is created a set of numbers where the answer includes decimal. God, how do you remember and think about all this stuff? This is what test engineers do. You're getting some practice. Look at my evaluation sheets. There's clues in there, the kind of tests I'm looking for your programs. If you cover the evaluation sheet, you should be all right. Some of them are very generic. I covered all the possibilities. Wow, that's tough. You can't cover them all. So let's do something like 101 and 200 and 200, right? Because that should give me a decimal place, I think. The total is 501 when we get there. But first, let's do this. Series equals 101. $501 is the total. If you need to use the calculator, use it. Definitely need it for this. 501 divided by 3 equals. Darn. That was a bad choice. So, quick fix. 102. Don't forget to change it down here. This often happens. I'd mark you wrong on something and you change it in the data, but you forget to change it in the formulas later on, and you forget to update totals and stuff. Any changes you make are probably going to carry down. Okay, so I expect the average to be 167.3. And the next bowling date, did you look it up yet?
12.
The 12th? Okay. 3/12, if it's wrong, we know who to blame. I think that's right. Volcker requires 5. I'm kind of running out of tests here. I've got a blank name, I've got an uncapitalized name, I've got a capitalized name. Isaac?
What if for the score you wrote it out? So 100.
That's text. That's my error message. Anytime you put text in for a number, I'm going to get an error. So that's test number 5. Save your errors for test number 5. Trevor?
What if they only did 2 games instead of 3?
We'll leave one of these blank. I can tell you what's going to happen. Your program's going to crash. That's an error test. So it's better. Maybe I don't know if it's better than that one, but it's another error test. Blank in a text box is considered the empty string. And what do you turn that into when you convert it into a number? 0? No, because that's what happens when you put a 0 in the text box. What happens is your program crashes, which we got to deal with, and we'll learn how. So I've got a couple of good error tests, but I don't have a good test for this, so I'm just going to kind of make one up. There's one more, though. This one rounded down, right? It'd be kind of nice if we rounded one up, because with the 666 to 1 decimal places, I expect to see a 0.7. I want to see that. So here I'm just going to put in another name and some date. Don't use the same date. Okay. So let's just do 3/1/2014 because I need another date. Volcker said so. Okay. And let's do 101 and 101 and 100. Total is 302. The average is 100.6667. Let's just make sure that I'm not lying to you here. 302 divided by 3 equals 100.666667. So that should round to 100.7. If it rounds or chops it off to 6, my bowler is going to be upset. Thank you. And this should be the 15th. If you can't come up with 5 tests, just give me another general one. But many programs accept decimal places, accept negative numbers. How about your gas mileage one? Negative numbers? Can't drive negative miles, can't have negative MPG, though some trucks you wonder about it. And start leaking gas before you even put it in. So no, not for those. Gas price negative? No. Decimal places? Yes. How about miles? Read the assignment. If you're not sure, ask me. But if I was paying for the gas and I was going and I need 6.3 gallons, I don't want you rounding that. Unless the assignment says to. All right, so now we have our bad test here. So I'm even going to put that in as the user's name. Bad test. Dun, dun, dun. Can't do anything bad with a date, right? Why not? Date picker won't let me. You go ahead and try and pick the 29th of 2014 to February, and it will. You can't. It's not even there. Can't pick it. Can't do it. So I don't have any bad dates, so let's just do 1/1/2014. But for my scores, I could leave it blank. That's an interesting test. All right. And here I could put, this is one of my favorites. That's a little L and two O's. None of you are old enough to remember the days when we had to use a typewriter. And typing numbers is a pain, right? So we cheated. Used a little L for a 1 and a capital O for zeros. And that's what we did. And a lot of old people like me still do that. So we want to capture that. And what else can we do? We could say nothing. That's text. Down here, we might not even get this far. Series equals nothing plus L00, 0, that's a little L00 plus nothing. The next one would kind of do the same thing, right? Try to divide it by 3, but the errors won't show up until it tries to do the math. And so actually, you know what? Here, you can put error. Because we'll never get to this one. After there's an error, the rest of them are just errors. We didn't see that in the meters to yards program because the errors, we did see it. Same thing happened. Next bowling date is an error. Seems odd. What's wrong with my date? Nothing. I should be able to pick a date. Won't happen. Because once there's an error in your calculations, your program's going to stop. That's something I don't like, right? Because we could calculate the date. In the future, I'll tell you how to keep going. But not this class. So down here, these are all errors. Please put your error test last. I want to see your good plan tests that these should stress my program first, and then your error test. One error test is all I require. So that's our test plan. Now our design, finally, is done. And so is the lecture. So that means we have a little work to do. You have 3 more assignments down the pike. If I look at the website, we can see that. Okay. All the evaluation sheets are there. For Unit 3, you have to do this gas estimate parts 1, 2, and 3. I consider that one assignment, but it shows up as 3 in the gradebook. Then you have to design this math program. I'm going to take a quick look at that. I've got a friend who's teaching very, very basic math to little kids. And we want to enter 2 numbers. Notice the 15 and the 4 are repeated over and over and over again. The user enters 2 numbers, and we display for them what those numbers added up looks like, what those numbers subtracted looks like, what those numbers geez, come on. It's a little sensitive. What those numbers multiplied looks like, what those numbers divided. Integer division. Integer division chops off the decimal places. And finally, modulus. Modulus means remainder. That's the computer term for remainder. We're going to teach our second graders what that means. Since all of you know about order of precedence, we might as well teach you about modulus when you're a second grader, so 10 years from now when those kids come up here, they already know what that means. So this is 15 divided by 4 has a remainder of 3. All right? This is what our program is supposed to do. How many inputs? 2. What's the first number? What's the second number? How many outputs? 6. There's a clue. 6 equations. The output is not 19. The output is 15 plus 4 equals 19. By the way, we've got to flip that around, right? But we're not going to. Because this is for second graders. We're not going to confuse them yet. 15 plus 4 equals 19. The most common mistake I get in this design is that there are 6 outputs, the results of addition, subtraction, multiplication. It's not just the results. It's the entire equation comes out. The entire equation. How do you put that in an IOP? Addition equation. That's it. What does that mean? We figure that out later in the design, and you will. But the most common mistake in the IOP is that you tell me that the sum comes out. It's not the output. It's part of this. It's the equation. Notice the 15 gets repeated over and over and over again. The 4 gets repeated over and over and over again. The inputs are actually displayed, echoed, 6 times. And you can shorten that in your IOP and call this an equation. That's a hint. Okay, so this one all at once, no pieces, parts. If you wish, you can grab me in the hall or in class. If it's a weekend and you want to say, here's my IOP, will you give it a quick once over? That's exactly what it'll be. I might miss something. It'll be a quick once over. Looks good. Okay. And then you send me your screen layout. How's this look? Then you send me your toe chart. You're on the right track. Go. If your IOP screwed up, yes, that'll affect you all the way down. But the others, you don't have to check with me every step of the way, but you can check with me every so often. If I'm in the room, ask me to take a quick look at it. So you're going to design that whole program. There's a worksheet, and you have to pick one of these 3. Typical question is, can I do more for extra credit? No, they're all so similar, it's not worth it. Not for me. If you wish to do them on your own, you can. Pick one that sounds interesting. This one has an international flavor. Ooh. This one's really good because it teaches, you're going to write a computer program to figure out if I need to give somebody's $96.13 and change, how many 50s, 20s, 10s, 5s, 1s, quarters, nickels, dimes should I give them? Sounds hard. It's not bad. Actually, this only has to deal with coins. It doesn't even have to deal with the $50 bills. And then finally, there's a quiz statistics program. It says I had 5, 6 students took this quiz. What's the average? What's the total? All that kind of stuff. Pick one. You might want to read through the details and say, this one sounds easiest, I'll do that. Okay. Or this one sounds the most challenging, I'll do that. That sounds better. And finally, or you just pick this one interests me, so I'm going to do it. It's up to you. So I need a due date. We already have a due date for this. That's next Friday. Next Tuesday, you will have lab. Only Tuesday. Thursday, oh boy, we start Unit 4. Here we go. So make good use of your lab time next Tuesday. Make some time this weekend maybe to work on some of these things. So if you're having trouble, you can ask me. So I'm jumping into Unit 4. How much of this stuff you want hanging over your head? Here's my suggestion. The worksheet. Due next Friday. That's when Part 3's due. You deal with it. Turn them both in. Turn one in early. A couple of people already turned to their worksheets. Not very long. Reasonable? Design number 2. I'm going to call it the math program, and I'm going to give you a little flexibility here. If you want to turn in your currency converter before you do your math program, I won't charge you points. Okay. I need a new design by what? When do we want the next? I'm going to put it under math, but I will give you flexibility. Following Monday. That's like that's from worksheet to next design, last design to this, or you want to push it out here to Friday. The more we push it out, the more overlap there is with Unit 4. Compromise Wednesday or Tuesday or 30th, right? And then one more design. Oops, forgot to turn that one on, excuse me. One more design. You want it on Friday or you want to mess up your weekend?
Friday.
I heard one, that's good enough. Notice the last one's only worth 15 because by this time you ought to be getting pretty darn good at it. So that would be Friday the 3rd of October. It will end December 17th. Remember that next Thursday, even though I'm starting Unit 4, I always guarantee you an hour of lab, right? So there'll be an hour of lab next Thursday, an hour of lab Tuesday, just an introduction to Unit 4 on Thursday. So you'll have 3 hours of lab next week, but I warned you a long time ago that there's never going to be enough lab time to do all of it. But Justin Walk suggested to you that you take full advantage of your lab time.